this video we're going to look at solving a system of equations by another method called substitution. In elimination, you effectively try to solve both equations at the same time in an equally balanced kind of way. In this method, substitution, what we do is force the constraints of one equation and impose it into the other. The solution of the resulting expression will thereby satisfy not only the equation that you plugged it into, but it also holds the constraints of the first equation, so it will solve both at the same time, but you effectively only solve one equation. So let's look at this first example. 3x plus y equals 13 and 2x plus y equals 8. Actually, you may realize this is quite easy to solve directly by elimination, but we'll use it to explain the method anyway. What we need to do is to try to express one variable in terms of the other from one of the equations. So I'm going to use this second equation here, and if 2x plus y equals 8, then that means that y equals 8 minus 2x. This is the same condition as the original equation. So if y equals 8 minus 2x, then that solution will definitely lie on the line. We'll impose that into the other expression. If 3x plus y equals 13, but we're going to use the fact that y is the same as 8 minus 2x, then 3x plus y, which is 8 minus 2x, needs to equal 13. So all we've done is replaced y by the thing that it's equal to from the other expression. Now we have 3x plus 8 minus 2x. In other words, we have 1x plus 8 equals 13. So x equals 13 minus 8, which is 5. So x equals 5. And then the original constraint that we used was that y equals 8 minus 2x. X is 5, so y equals 8 minus 10. So y equals negative 2. We can check it's correct. If 5 negative 2 works, then 3x plus y should equal 13 in the second equation. If x is 5, 3x is 15. If y is minus 2, then 3x plus minus 2 is indeed 15 plus minus 2, which is 13. So it does work. So again, all we did was take one equation, express one variable in terms of the other, and then replace that variable by what it's equal to in the other equation. Okay, so the thing to do is to try to find a variable which is by itself. There's no multiplier in front of it. And in these two equations here, we notice in equation 2 that we have 3a minus b. We have a b by itself. If 3a minus b equals negative 9, then 3a equals negative 9 plus b, or in other words, 3a plus 9 equals b. b is the same as 3a plus 9. That is the same condition as equation 2 started off with, it's just written a different way. So b equals 3a plus 9. So now let's put that in equation 1. 4a plus 5b is 7, but b was the same as 3a plus 9. So expanding the bracket, we have 4a plus 15a plus 45 equals 7. So 19a plus 45 equals 7. So 19a equals 7 minus 45, which is negative 38. And so a is negative 38 divided by 19, which is negative 2. And the original constraint was that b is 3a plus 9. b is 3 times a plus 9. If a is negative 2, then 3a is negative 6. So b is negative 6 plus 9, which is 3. So the solution is a equals -2, b equals 3. And in this third example, again, we need to try to find one variable which is by itself an easy one to make into a substitution. And again, we can see in equation 2, x minus 7y is 38. So adding 7y to both sides, this will give us x equals 38 plus 7y. It's the same condition, it's just written a slightly different way. So we're using the condition of equation 2, so let's substitute it in equation 1. So if 4x plus 3y is 28, and we want x to equal 38 plus 7y, then we just replace x by 38 plus 7y. 4 times 38 is 152. 4 times 7y is 28y, plus the 3y equals 28. So altogether we have 152 plus 31y equals 28. Take the 152 off both sides. 31y is 28 minus 152, and 28 minus 152 is negative 124. So if 31y is that, then y is negative 124 divided by 31. A negative divided by a positive is a negative, and 124 divided by 31 is 4. So the answer is negative 4. Y is negative 4. If y is negative 4, and we know that x needed to equal 38 plus 7y, then x will equal 38 plus 7 times negative 4, which is 38 minus 28, which is 10. So the final answer is that x equals 10, y equals negative 4. So it's a little less obvious than elimination, but sometimes it is a very appropriate thing to do, especially if you can find just a variable all by itself, like in this case. Every method works if you do it the correct way. There is no best method to use, and it's all a question of confidence and practice. Good luck.